welcome back to our Kotlin Start or Native Android Development course. In this video, we're going to actually start learning some Kotlin code, so this is exciting. Let's go ahead and get started. This is why we are teaching and taking this course. So if you know anything about coding, you know the most basic thing that you need to learn is variables. And a variable is essentially a container that you can use to put data in and store it, and then use it again and again at multiple points throughout any program. So in Kotlin, you have basically you have number data types, you have text data types, you have a Boolean data type, which we'll talk about what that is later. But if you look at the number data types, you'll notice that you may have seen a chart like this before, and if you haven't, you can see it now. You'll notice that you have something called a byte, which its size is 8 bits, and then it has a range of what kind of number it can store within that byte. And then you have something called a short, which is another data type that says size 16 bits, and then it has again a range for what size number you can store within that. And then the same thing for an int and a long. Now, I'm just going to show you really quickly where these ranges are coming from. So in computer code, so in math, when we count, we typically use a base 10 counting system. So you start at 0 and go all the way up to 9, and then you start over at 1 0, 1 1, 1 2, etc. And then when you get to 1 9, you start again at 2 0, 2 1, 2 2, and it just goes on and on. Now, computers do something very similar, but instead of having a base 10, where you have numbers from 0 to 9, you have a base 2 where you have numbers from 0 to 1. So a computer is going to go 0 0, 0 1, 1 0, 1 1, 1 0 0, 1 0 1, 1 1 0, and so on. And the reason for that is essentially in a computer you have, for all of these bits, what they call a bit, you have two possible states that you can have. You can either have it be on or off. So if we I'll show you, if you pull up your Windows calculator and change from your standard view over to your programming view. Now in here, if we want to see where these numbers are coming from, first I'll show you. If we click this little button right here, it'll show us our bit toggling keyboard. So if I'm on decimal, which decimal is our base 10 counting system that we use in math, and I type 1, you can see in binary down here, it gives me 1 bit. But if I take 2, then it gives me 1 0. 3 is 1 1. 4 is 1 0 0. 5 is 1 0 1, and so on. So what happens now, if I take, say, for my byte, my max value is 127. So if I type 127 here, you can see that immediately I have 0 1 1 1 1 1 1 1. Now you might look at this and think, well, wait a second. You just said that I have 8 bits, and for my maximum value, which is 127, why are we only using 7 of those bits? This last one here we should be able to use as well, and if I toggle that to a 1, that should make it 255, right? Well, you might think that, but you'd be wrong, and here's why. Because your range on your byte goes from 127 to negative 128. So negative 128 all the way up to positive 127. So you need a way to store negative values as well. So this last bit is going to be referred to as the sign bit. And if that is set to 1, that's actually, instead of making this 255, that's going to turn this into a negative number. So real quick, if we change up here on your calculator, you have a keyword, which is this full thing. But if I change that to a D word, it gives me half, and then half again for a word, and then byte. So here's our byte in Kotlin, which is 8 bits. And if I wanted to type, so 127 is 7 ones, but let's say I want to switch that, and I want to maybe make that negative 128. So if I change that to negative 128, and then switch over to my bits again, you can see now I have 1 0 0 0 0 0 0 0. So negative numbers are going to work essentially backwards from your positive numbers. So for every time you have a 0 on your negative numbers, it's going to essentially treat that like it was a 1 on a positive number. So if I change this, it's going to make it negative 127. Whereas if I have all of these set to 1, it'll make it negative 2. Or sorry, negative 1 if they're all set to 1. So that's why you have a value of negative 128, which is the absolute maximum you can have here on your byte. You can have 1 with all zeros is negative 128, or you can have all ones is going to be positive 127. That's where that range is coming from. And you can see that's the same thing. If I change it to a short, and then I type in, let's say I want to type in my max number, 32767. Well, that's what we would expect. The sign bit stays at 0, and then the rest of them all go to 1. Now let's say I want to make that negative. Well, now, again, that's what we expect. The sign bit goes to 1, and then the rest of them, except the last one, go to 0. Because if you'll notice, the negative number can always go 1 lower than the positive number can go high. So if we go back to the calculator and we toggle that, well, there's our maximum negative number. And again, if we change that word to a D word, which is going to be our int, and we go to binary, and let's go ahead and enter our integer value, or maximum integer value, which is 21474833647. And here you go, the same thing. We have 0 with all ones following after it. And then let's say you want to look at your long. Well, go back to the keyword on your calculator, and you can type in 9223372036854775807. And there you see we have 0 with all ones after it. So that's where these ranges are coming from. And the reason that you have different ranges on numbers, you might think, well, why don't I just always use a long, because that can store the highest number. And that's true, but it's also going to take up the most memory. And if all you're doing is counting someone's age, there's no reason to store somebody's age in a long variable, because they're never going to be, I don't even know what this number is, 9 quadrillion years old. So for an age, a byte would be totally sufficient. Whereas if you're looking for something like storing, say, the American national debt, which is like 31 trillion, then a long would be the right value to store that in. So for different types of data that you're storing, it makes sense to use different size containers for that. So let's get into Android Studio here and actually look at how we can start creating variables. So in Android Studio, and this is just that same example project that we created in the previous video, if you go to your main activity file, and then in here, you should see class main activity. And we'll talk about what a class is later and what that means. And then inside that, you'll see override fun on create. And then it's going to have saved instance state, bundle. And then after that, you have this curly bracket. And if you click on that, it'll go yellow. And you can see that that is actually paired with this curly bracket down here. So this whole block of code right here is a function, which is where that fun comes in. And this onCreate function is going to be run when your application, when your activity is created. So for now, we're just going to put all of our code within this onCreate function. And then later, we'll talk about why that's a bad idea. But for now, before you know what classes are and functions are, this is just a good place to start. So for example, if I wanted to store my age and a number, I could very easily do that. I could say val my age equals, and I could just put my age here, which is 31. So I could say val my age equals 31. But the problem with that is, again, as I told you on that on those ranges, we have negative 128 to 127, and then you have negative 32,000 to positive 32,000, and then what is that? 2 trillion, negative 2 billion to positive 2 billion. So Kotlin has something called type inference, which means if I don't specify what type this is, then it's going to default to your default number type, which is going to be an int. And the way you can specify is you can put a colon after your variable and then type int, and you'll see down here the Kotlin compiler, or the IDE rather, will give you a list of things that it thinks you're trying to type. So int is what I want, Kotlin, and that stands for integer. But the integer range is way bigger than we need just to store my age. So what you can do instead is you can just do byte. So if I do it like that, it's going to store that in a byte, and it's going to take less room. So nowadays, it's not as big of a deal because most modern day computers and phones have a decent amount of RAM. So the difference between using a byte and using a short or an int doesn't make as big of a difference in the actual execution of your code. But still, it's a good practice that if you're doing a variable that's not going to get above 100, for example, like my age, then it's a good idea just to go ahead and put that in a byte anyway. Let's go ahead and make some different variables for the types that we've just talked about. So you have your byte, and I can set that equal to 127. But you'll notice there's actually going to be a problem here. Is I set my value for my byte to 127, which is within the range of the byte. But if I hover over byte, you'll notice that my down here, my byte is actually, it says it's of type int. So it's an integer type, and that's not what I want. So the reason for that is if you don't specify a data type on a whole number, on an integer number, it's going to assume that you want that to be an integer. So we need to actually specify that we want this to be a byte. And now if I hover over byte, you could see that it's storing this byte variable as a byte instead. Now we can do the same thing for a short. Make a short, and again, we're going to have to specify so it doesn't store it as an integer, say 2500, and then we can make an integer, and this one we don't have to specify. I mean, this can be whatever size you want, assuming it's within the range of the integer. And if you hover over that, it's going to default to the integer, so you don't have to specify. You can, if you want to, you can do that, and that's going to technically do the same thing. But you can see your compiler here has highlighted that in light gray, and the reason is because that specification is unnecessary. So we don't need to do that, and typically if stuff is unnecessary, we don't do it in our code. And then after that, you can do a long. And so let's say we do 1, 2, 3, 4, 5. Whoops, put a V on that. So val long equals 1, 2, 3, 4, 5. But again, this is going to be of type int. So if you want the compiler to know that we want this number to store it within a long variable, you can do one of two things. You can specify here that this is a long, and now you could see that we're storing this in a long data type. Or instead of specifying it as a long there, if you give it data that's a long, so 1, 2, 3, 4, and then I put a capital L after that, that tells your compiler that this number is meant to be a long data type. So now if I hover over this long, you can see it's also stored as long. There's two other fairly important numerical data types that we need to talk about. So if you look back on here, we have these, the byte, the short, the int, and the long that we talked about previously. But you also have floating point types, which means if you have a fraction or a partial number or a decimal number, then you need to store that with a decimal place. So there's two types for that. There's float and then there's double. Now, your float is going to have 32 bits, and then your double is going to have 64 bits. And in the compiler, just like your other numbers are going to default to an integer if we don't specify. So if I come here and I type val float equals 3.14, I don't know if that's the value of pi, and then if I hover over that, you can see that it's actually defaulted to double there. Now we don't want that to be a double, so again, you can do two things here. You can specify here that this is supposed to be a float, but then it's going to complain because you're giving a double value to a float variable. So the way that we fix this is after the 3.14, you put a capital F. But if you put a capital F, you no longer need that float specification because the type inference within Android Studio is going to know that if I'm handing a float value to a variable, then we want that to be a float type. And then for the double, we can just hand it a number. So double equals 5.258. And this one, you can see, is going to be saved as a double by default. Beyond this, well, there's actually two other numerical data types. You have your hexadecimal. So if I do 0x and then some number, so 1, 2, AB, this is going to save it as hexadecimal. And if you don't know what hexadecimal is, if you come over to your calculator, you could see our hexadecimal number is this 7. In here you have 1 through, well, you have 0 through 9, and then you also have A, B, C, D, E, and F. So this is just a 16 base counting system instead of a 10 base counting system, because sometimes in computers 16 base is a lot easier to count by than a 10 base or a 2 base. So that's what hexadecimal is. So you have all of the characters from 0 to 9 and then A through F as well that you can add to that. So if I do like 0xFFFF, this is a hexadecimal number. And those are going to be saved again as type int, unless you specify that. So this, even though I'm formatting it like a hexadecimal number, this is going to be saved within a int data type because it's still just a whole number. But you can also change that. So if I want that to be a long, I can tell the compiler that I want this hexadecimal to be stored within a long. And then there's one other option for formatting your numbers, and that's binary. So if you want a binary number, all you have to do is, instead of 0x for hexadecimal, you do 0b for binary, and then we can do, there's our 127 from before. So that's going to be all of your, well, this is all of your numeric data types that we'll commonly use, and then these are two different formatting ways to do that. Now, let's go ahead and talk about, well, actually, before we move on from the numeric data types, one thing that's kind of important to mention is that these are all objects. And if you don't know what an object is, we'll worry about that later when we get to object-oriented programming and classes. But for now, just know that what an object, the fact that this is an object means that this data type byte or short is going to come with a series of functions, predefined functions that we can use. So if I want to make a new variable and I call it number equals, and let's say we want to take our byte variable and we say byte 2. Now here we can convert it to anything we want. We can say to double, to long, to float, to integer, to short, to a string even, which is a text variable. So if we want this number to be saved just in ASCII text instead of in an actual number, you can do that. And then also you have your unsigned byte. So in Kotlin, you'll see a ubyte, a uint, a ulong, a ushort, and so on. And that means unsigned. So if you use the unsigned data type, our byte, if you remember on our calculator, our byte went all the way up from, let's see, it went from, so if we type 127, and then if you look at your bits, you can see we have the 1111111, and then if you click that last one, now it's 255. So if you have an unsigned number, that means you no longer need this last one to be used for the sign, whether it's positive or negative, which means you can go from 0 all the way up to 255. So it just increases your range. So you also can do the unsigned versions of all of these data types. And then number, so like byte dot to, and let's say we want to convert it to a short, you can do that. And now you can see this number, even though I'm dumping the data from byte, which is of type byte, this number variable is going to be inferred to a short. So you have a whole bunch of different conversion functions that come with each one of these data types that you can use. Now, one more thing to mention here. Let's say I have my age is 31, but every year people have their birthday, which means you're going to need to change your age. So if I have my age variable and I want to change that, so let's say I'm 31 now and I want to add one to it. So I say my age equals 32. You'll notice this is going to be underlined in red. And the reason for that, it'll tell you val cannot be reassigned. So this val keyword is essentially you're defining a value that's going to be constant throughout this code file. If I want this to be a variable value, meaning that this is going to change, I have to actually call that a var. So this is pretty important in Kotlin programming, the difference between a val and a var. Typically, we use val for values that we know are not going to change, and you will definitely increase your performance by doing it that way. And then we use var for values that we know are going to change. So let's look at what you can do with your unsigned numbers or your unsigned data types really quickly. So if I want to make it an unsigned int, all I do is val uint equals, and by the way, this uint here is just the name for the variable. I can name that whatever I want. I could name that my uint. I could name that my variable. I could name that my value. I can name that Bob. I can name that whatever I want to, but just for now, I'll just call it a uint. And here, if I do val uint equals 100, or 1000 rather, that is going to default to int. But if we want this to be unsigned, all you have to do is stick a lowercase u after that. So now if you come down here, you can see we're of type uint, so unsigned int. And if I want to do the same thing with a byte, I can do val ubyte equals 255u, but you're going to have a problem here. So now if I hover over ubyte, you can see actually this is an unsigned int, and that's the same thing we had above, where when I made any number and it defaulted to an int because of the type inference within Android Studio and Kotlin. This is also going to default to an unsigned int if I pass it an unsigned number within that range. So what I need to do is specify this as a ubyte. And now you can see that my ubyte variable is actually of a ubyte data type. And same thing, you have a unsigned long as well. So ulong equals, and let's just give that a number. And then instead of just doing L, what you'll do is lowercase u, capital L, and that means an unsigned long. So now we have our ulong. So that is really all that we have to talk about for our numeric data types right now. Join us next time and we'll go ahead and move on in our course and talk about some of our different variable types that we have for text and for logic that we can use as well. And then we'll also cover our operators. So we hope to see you in the next video. Like and subscribe if this is helpful for you.